Hey everybody, hope you're doing well today. Got a nice math lesson for you. Just wanted to let you know that praying for all of you and your family. I know there's a lot of people not doing too well with COVID. I just hope that we get to be back in school here soon. Just hang in there and God will see you through, so don't worry. Anyhow, we're going to start this new lesson here on complex numbers and solving quadratic equations. Complex numbers are something that's new to probably all of you guys. It's a form of numbers that actually has an imaginary part to it, okay? You might remember that imaginary numbers come from negative square roots. If not, that's alright. We'll get into that here in a second. Alright, so here I want you guys to remember what perfect squares are, okay? They're numbers that you get from multiplying a number by itself. Like 12 squared is 144, so we say 144 is a perfect square. So is 121, 100, 81, 64, 49, 36, 25, 16, 19, and 4. Okay, these are all from a number times itself. Okay, like 49 is 7 times 7. All right. Now, to simplify a number underneath a square root, or the technical name is a radical symbol there can be no perfect square factors in that particular number. Okay, so like the number 8 has a perfect square factor of 4 in it, so you'd have to simplify it. Okay, so let me give you another example here. So like say the number 48. Okay, so the square root of 48 can be simplified because 48 has a perfect square factor in it. Alright, so you might be wondering which one it is. Well, it has to be less than 48, okay? And you want to try to pick the largest one that it is. So, I mean, you might have to play around with it, but 16 is the largest perfect square factor that's in 48. So what you want to do, if there is a perfect square factor, you want to split up 48 into the perfect square factor times whatever number is left. Okay, that would give you 48. So like 48 divided by 16 is 3. So square root of 48 is the same thing as saying the square root of 16 times the square root of 3. Alright, and then we could simplify this as simply 4. Square root of 16 is 4 times the square root of 3. Alright, hopefully you remember how to do that. We'll be doing that occasionally throughout the next couple lessons. Alright, so first thing in this lesson is how to solve some equations by using square roots. Okay, this is something that you might have not done for a while, but here we have a quadratic equation. A quadratic equation is just an equation with x squared. Okay, so to solve a quadratic equation, if there is no term that's linear, in other words, no bx term, you can solve it by taking the square root of both sides. Why? Because the square root of x squared is equal to x, okay? And that helps to eliminate the square part that's on x, all right? So, however, when you square root both sides of an equation, there are two possible answers that when you square them give you the same number, okay? Both a positive number and a negative number, when you square them, give you the same thing. So when you square root both sides, you have to use a plus or minus symbol to account for this. Alright, so let's take a look at how you'd solve a little equation by square roots. Okay, so here you see there is no linear term, it has a quadratic term, x squared. Alright, and so we can solve this equation by square roots. First thing you want to do is isolate the x squared term. So we'll just move over the 486 to the other side by just adding it over, so it becomes positive 486 over here. Okay, so we have 6x squared equals positive 486. Alright, and then once again you want to isolate x squared, so you're going to get rid of the 6. So you would divide both sides by 6. Okay, and 486 divided by 6, let's see what that is. That's 81. Okay, so you got 81 here. So you have x squared equals 81. Now this is where you want to think, aha, I need to get rid of the square. So how do I do that? I use the square root. So I square root both sides, but as soon as I put that square root on both sides, that's when you have two possible answers, okay? Because a negative 9 squared is the same thing as positive 9 squared. They both will give you 81. So your answers are actually two of them. X is equal to plus or minus 9, because the square root of 81 is 9. Alright? So hopefully that isn't so bad there. Alright? Oops, I guess I could have typed that in, or didn't have to type that in. Okay, here's a couple more examples here. Let's just do the first one here for the sake of time. Okay, so here you want to get x squared by itself, so we're going to start off by dividing both sides by 3. Alright, so we have x squared by itself now equals 8. Alright, so let's square root both sides. Now once again, don't forget the good old plus or minus sign when you square root both sides. And now what's the square root of 8? There is no square root of 8, Mr. Yakko. You're right, but you can actually simplify this, because the square root of 8 contains perfect square factors of 4. Okay, so 4 times 2 is 8, so we want to split this up to simplify this. So your answer would be plus or minus 2 root 2. Okay, so that's how you would do that one. This one, basically very similar. This time there's just a fraction. So we add both sides, a fourth to both sides. Then we square root both sides. Alright, and then remember plus or minus symbol. Okay, so our answer is plus or minus the square root of 1/4. Alright, so when you're simplifying this, you want to think of splitting the fraction into the square root of the top and the square root of the bottom. Okay, so plus or minus the square root of 1 is 1. Plus or minus the square root of 4 is 2. Okay, so this is just plus or minus a half in the end. Sorry, that doesn't look super neat there. Okay, so not so bad so far. Okay, now here is something that is mind-blowing to you. There are numbers called imaginary numbers out there, okay? And they actually have real applications to them. Like electrical engineers use imaginary numbers because it makes solving equations a little easier in advanced calculus type equations. But the applications aren't too much for the common man here. Okay, so what is the imaginary number? We actually use the letter I to stand for it. It's defined by the number whose square is -1. Okay, so in other words, I squared is equal to -1. Okay, so the imaginary number squared is equal to -1. And if you square root that, that would mean that I is equal to the square root of -1. Okay, so you want to really keep track of this fact right here. This is the key for imaginary numbers, these two things. I squared is equal to -1, and I is equal to the square root of -1. Okay, so anytime you have the square root of a negative, that's really, you could make that into an I. Okay, because back in the day I told you you can't take square roots of a negative, because remember, nothing times itself is a negative number. Well, now mathematicians have decided to call that something I. Okay, the square root. So what times itself is negative? Well, it's I. Okay. Okay. So an imaginary number takes on the form b times I. So it could be a number that's a real number times I. Okay. So here's a key property for imaginary numbers. Okay, for any positive real number a, if you take the square root of -a, then that is just equal to I times root a. Alright, so in other words, let's go ahead and show you here what that actually means. Here we got the square root of -16. Alright, so we have the square root of a negative number. So what that property says we could do is take out an I for that -1, okay, that negative that's in here. Okay, then we would just be left with the square root of 16. Alright, now you'd actually want to simplify this as 4 times I. Okay, imaginary numbers, you put the real number part in front, and then the imaginary number part. Okay, so that's how you would simplify square root of -16. Which is, there it is, much clearer. Okay. Example 3. simplify the square root of negative 54. Okay, so first, once again, you just take out the I, and then you just simplify the square root. Okay, so you need to know what perfect squares go into 54, and that's just 9 is the perfect square that goes into 54, and the other number that would be left is 6. That's not a perfect square, but you always get one that is a perfect square and one that isn't. Unless the number itself is a perfect square, then you could just square root it. All right, and then so you'd simplify this as 3i root 6, because you can simplify square root of 9 as 3. Okay, so you have 3i root 6. All right, so now this leads to complex numbers. All complex numbers are basically any number you could possibly imagine, including the imaginary ones. Okay, so it's combining real numbers, which are the a part, and the imaginary numbers, which are the bi part. Okay, so you got the real part and the imaginary part. Alright, let's check out example 4 here. What we have to do is just write a number that looks like this in complex form, a plus bi. Okay, so real then imaginary. Okay, first what we got to do is take this negative underneath the square root and simplify it down. So we pull out the I, and we have the square root of 121. And 11 times 11 is 121, so we could write that as 11i minus 7. Now notice it's a plus bi. This is just a little bit backwards, so all we got to do is rearrange the terms and bow, there it is, a plus bi form. Okay. Alright, now one of the cool things about imaginary numbers, it allows us to solve quadratic equations that we could never solve before, right? So we could actually figure out what this would be here. So let's actually go ahead and solve it. Remember, you move over the constant term first. Okay, we're going to try solving it by square roots like we did on the previous problems. Alright, we divide both sides by 9 and we get negative 6. Now we square root both sides. Alright, and when we square root both sides, we should remember our plus or minus sign. Okay, as soon as we square root both sides. Now, we have the square root of negative 6. Well, what's the square root of negative 6? Well, that's just plus or minus I root 6, because you can pull out the I. Okay, anytime you have a negative underneath the square root, you simply get rid of it by pulling out the I. Okay, so you have I root 6. And don't forget your plus or minus sign. And there you go. We solved an equation that would previously have given us an error. Alright? So, I want you guys to try this one. In fact, I want you to try it and post your answer to this on Classroom so I can tell that you have been watching this video. Alright, we're going to keep on rolling here though with some info. Okay. So we can apply all the operations of normal numbers to complex numbers. They distribute to, they add, you can do pretty much all the stuff that we would with normal numbers with complex numbers, which is pretty cool. Alright, so to add or subtract complex numbers, all we got to do is add the real parts together and add the imaginary parts together separately. Okay, it's kind of like combining like terms when you combine real and complex, when you combine complex numbers here. Alright, so if we're combining these two complex numbers, I just want to think about it as combining like terms. You can combine the numbers and you can combine the i's. But first, before we do that, we need to distribute. Okay, so we're going to distribute the minus sign in. Wa and wa. Okay, so we have negative 4 plus 8i. Okay, so after you distribute the minus sign in, next, what we're just going to simply do is combine the real parts and combine the imaginary parts. Okay, so I mean, you don't even need to write this step. You could just think, okay, I'm combining 6i with 8i, so that makes 14i. Okay, and 3 minus 4 is negative 1. So there's your final answer in a plus bi form. Okay, I'm going to keep rolling in part 2 with more of this stuff, so make sure you watch that video too, and I'll see you in a few.